Continue the exercise 1.2 from the chapter differentiation. In that, the next problem is differentiate the following with respect to x, cot inverse of sine 3x upon 1 plus cos 3x. Now, what is given? Y is equal to cot inverse of sine 3x upon 1 plus cos 3x is given. Now, we have to simplify it. Now, how to simplify it? This sine 3x using the formula sine 2 theta. Sine 2 theta is equal to 2 sine theta cos theta. So here we will use that formula 2 sine 3x by 2 into cos 3x by 2 using half angle formula. Here also using the same formula 1 plus cos 2 theta is 2 cos square theta by theta. So 1 plus cos theta is 2 cos square theta by 2. 1 plus cos 3x is 2 cos square 3x by 2. So here 1 cos 3x, here 2 cos 3x. So 1 will cancel to each other. This 2 will also cancel to each other. And this sine upon cos is, you get tan. Now we can write this tan as 90 cot of 90 minus theta. So now this cot and this cot will cancel to each other and you get pi by 2 minus 3x by 2. So we differentiate this with respect to x. So derivative of pi by 2 is 0 and derivative of 3 by 2 into x is minus 3 by 2 into 1 is minus 3 by 2. So the derivative of this given function is minus 3 by 2. The next function is tan inverse of cos 7x upon 1 plus sin 7x. What is given? Y is equal to tan inverse of cos 7x upon 1 plus sin 7x. So again using the simplification, this here that 1, this 1 can be written as sine square 7x by 2 plus cos square 7x by 2. This sine 7x can be written as 2 sine 7x by 2 into cos 7x by 2. So in denominator, we can write that expression as is using the form a square plus twice ab plus b square as a plus b bracket square. And in numerator, cos of 2 theta is equal to cos square theta minus sin square theta. So using that formula, cos of 7x can be written as cos 7x by 2, cos square 7x by 2 minus sin square 7x by 2. Now here there are, in denominator there are 2 and in numerator a square minus b square, using that formula a minus b, a plus b. So here this one of the factor cancel to each other and we get cos 7x minus sin 7x, cos 7x by 2 minus sin 7x by 2 upon cos 7x by 2 plus sin 7x by 2. Now in this, divide numerator and denominator by cos 7x upon 2. After dividing the cos numerator and denominator, you get 1 minus tan 7x by 2 upon 1 plus tan 7x by 2. This is nothing but tan pi by 4 minus 7x by 2. So again this tan inverse of tan x is x. So using that property, we get y is equal to pi by 4 minus 7x by 2. And we can differentiate this function with respect to x. We will get minus 7 by 2. The next function is tan inverse of square root 1 plus cos x upon 1 minus cos x. Simple. 1 plus cos x can be written as 2 cos square x by 2 and 1 minus cos x can be written as 2 sin square x by 2. So 2 cancel each other. Cos square upon sin square is cot square, which will that square will cancel to the square root and we get tan inverse of cot x by 2. This cot can be written as 90 minus cot of tan of 90 minus x by 2. So again this tan inverse, it cancel to each other, pi by 2 minus x by 2. Now we can differentiate it with respect to x. You get minus 1 upon 2. Okay. The next function is tan inverse of cosec x plus cot x. Now here we will simplify it. How? This cosec x we will write it as 1 upon sin x and this cot x we will write as cos upon sin x. So here denominators are same. So what we get? It is the y is equal to tan inverse of 1 plus cos x upon sin x. But this 1 plus cos x can be written as 2 cos square x by 2 and sin x can be written as 2 sin x by 2 cos x by 2. 2 cancel. Cos x by 2 cos x by 2, 1 will cancel and what you get? Cos x by 2 upon sin x by 2 is cot x by 2. Again using allied angle formula, this cot of theta can be written as tan 90 minus theta. Okay, then using the property tan inverse of tan theta is equal to theta. So we get pi by 2 minus x by 2. Differentiate that with respect to x, we get d by dx of pi by 2 minus 1 upon 2 times d by dx of x. Pi by 2 is a constant, its derivative is 0 and derivative of x is 1. So we get minus 1 upon 2. The next function is y is equal to cot inverse of under root 1 plus sine 4x upon 3 plus under root 1 minus sine 4x upon 3 root 1 plus sine 4x upon 3 minus root 1 minus sine 4x upon 3. Now how to simplify it? This 1 plus root of 1 plus sine 4x upon 3 can be written as, is using the same thing. This 1 can be written as sine square 4x by 3 and now this 1 can be written as sine square 2x by 3 plus cos square 2x by 3, and this sine 4x upon 3 can be written as 2 sine 2x upon 3 into cos 2x upon 3. Here we are using a double angle formula. Sine 2 theta is equal to 2 sine theta cos theta, and this here 1 for 1 we are using the first fundamental identity, sine square theta plus cos square theta is equal to 1. Now here is a plus, so a plus b bracket square. Now here is minus, so a minus b bracket square. Here is also a plus b bracket square, a minus b bracket square. Now each of the terms having the bracket square, so the square root and the square will cancel each other, and you get cos square 2x upon 3 plus sin square 2x upon 3 plus cos square 2x upon 3 minus sin square 2x upon 3, and similarly at the denominator. So what will happen if we remove the bracket? This sine and plus sine minus sine will cancel to each other. And then cos and cos will cancel to each other. And you get 2 cos 2x upon 3 and upon 2 cos 2x upon 3. 2 gets cancel. Y is equal to cot inverse of cot 2x upon 3. So cot inverse of cot x is x. So using that property, you get y is equal to 2x upon 3. We will differentiate this with function with respect to x, so that we get dy by dx is equal to 2 upon 3. Next function, differentiating the following with respect to x. Sine inverse of 4 sine x plus 5 cos x upon root 41. In solved example, I explain one of the method. Here I am going to explain another method. Given y is equal to given expression, then we will divide this root 41 to first term and second term. So sin x into 4 upon root 41 plus cos x into 5 upon root 41. This is our equation number 1. Now, now here is a sine inverse. Out of the bracket, it is sine inverse. So here we must get sine a plus b or sine a minus b. Okay, if we are unable to get sine a plus b or sine a minus b, try to get cos a plus b or cos a minus b. Okay, so here sine a cos b plus cos a sine b. So here this must be cos alpha. Okay, so cos alpha is equal to this. So how to obtain the sin alpha? We can obtain the sin alpha by using under root sin square alpha plus cos square alpha is equal to 1. So sin alpha is equal to square root of 1 minus cos square alpha. Using that identity, you can find the sin alpha, which comes out to be 5 upon root 41, which is here 5 upon root 41. This is the process that I have not explained in the solved example. In solved example, what we did, this is our cos alpha, this is our sin alpha. We are just directly take out cos alpha and sin alpha, and then we have proved that the sin square alpha plus cos square alpha is equal to 1. That's it. Okay, so we will put both of these in this equation number 1. What we get now, from this sin alpha and cos alpha, we obtain tan inverse of 5 upon 4 alpha. Now we have put the values in the first equation. So sin x cos alpha plus cos x sin alpha is nothing but sin x plus alpha. Now sin inverse of sin is cancel to each other and we get x plus alpha. But what is alpha? Alpha is tan inverse of 5 by 3, which is a constant. So when differentiating with respect to x, the derivative of this alpha is a constant, its derivative is 0. So we get derivative of x only and it is 1. Cos inverse of root 3 cos x minus sin x upon 2. Now here also you can divide separately by this 2, cos x into root 3 by 2 minus sin x into 1 upon 2. Now here also we can directly put the values. What is the value of root 3 by 2? Now here is cos, so we must have cos a cos b minus sin a sin b. So cos x is already there, so this term must be cos. So what is the value of cos? For what angle? Cos of that angle is root 3 by 2. It is cos 30. So cos pi by 6. We can directly put that value cos pi by 6 minus sin x into sin pi by 6. Okay, no harm. Now here cos alpha is equal to root 3 by 2 and therefore sin alpha is equal to under root 1 minus cos square alpha. We can verify that sin alpha is 1 upon 2. So using these two, sin alpha and cos alpha, you can find the value of tan alpha. Tan alpha is 1 upon root 3. So alpha is tan inverse of 1 upon root 3. So y is equal to cos inverse of cos x cos alpha minus sin x sin alpha. So cos inverse of cos x plus alpha, because cos a cos b minus sin a sin b is cos of a minus a plus b, addition angle formula. So again here cos inverse of cos x is x. Using that property we will get y is equal to x plus alpha. Now we will differentiate this function with respect to x. Derivative of x plus derivative of alpha. Derivative of x is 1, but derivative of alpha is tan inverse of 1 upon root 3, which is constant term. So its derivative is 0. So we get dy by dx is 1. Next function, sin inverse of cos of root x plus sin root x upon root 2. Also same, divide numerator both separately divide by root 2. So 1 by root 2 cos root x, 1 by root 2 sin root x. Now here is also there is sin inverse. So here we must give sin of sin alpha cos root x plus cos alpha sin root x. We can put directly the value of sin pi by 4 and cos pi by 4. Okay, so here just like this, sin pi by 4 cos root x plus cos pi by 4 sin root x. It is nothing but sin pi by 4 plus root x. Again sin will cancel each other and we get pi y is equal to pi by 4 plus root x. So differentiating with respect to x, we will get dy by dx is equal to d by dx of pi by 4 plus d by dx of root x. But d by dx of pi by 4 is 0 and d by dx of root x is 1 upon 2 root x. So the derivative of the given function with respect to x is 1 upon 2 root x. This is the derivative of the given function. Cos inverse of 3 cos 3x minus 4 sin 3x upon 5. Okay, y is equal to the given expression. We can write, then separately divide by this 5. You get this term. Now here the outside the bracket is cos inverse, so we must have here cos a plus b or cos a minus b. Okay, so one cos is already present, so this must be cos, so that we can get cos a minus b or cos a plus b, cos a cos b minus sin a sin b. If we take this is this has to be cos alpha is equal to 3 upon 5, then we will take sin alpha as 4 upon 5 and we will check whether sin square alpha plus cos square alpha is equal to 1 or not. Okay, here I have solved this example by different method. This is cos alpha. From this cos alpha I have find out the sin alpha, and sin alpha is comes out to be 4 upon 5. So we put the given values in this equation. So cos 3x cos alpha minus sin 3x sin alpha, it is nothing but cos 3x plus alpha. Now again using the property cos inverse of cos x is equal to x, we get y is equal to 3x plus alpha. Differentiating with respect to x, we get this expression. Derivative of 3x is 3 and derivative of alpha. Alpha is tan inverse of 4 by 3. So its derivative is 0 because there is no x in this expression. So the derivative of the given function is 3. The next example is cos inverse of 3 cos e raised to 3x e raised to x plus 2 sin e raised to x upon root 13. Here is also what we will do. We will divide separately by root 13. Now again here is the cos inverse is there. So we must have in bracket cos a plus b or cos a minus b. For that the terms must be like this: cos a cos b plus sin a sin b. So we have to take this first term as cos alpha. Okay, cos alpha. From that we can obtain sin alpha. Sin alpha is square root of 1 minus cos square alpha. Put the value, simplify it, you will get sin alpha as 2 upon root 13, which is already present over there. Okay, it is there. So no harm to put the values of cos alpha and sin alpha in this expression. Okay, also they have found out the value of tan alpha. So alpha is equal to tan inverse of 2 upon 3 and y is equal to cos inverse of cos e raised to x cos alpha plus sin e raised to x sin alpha. Therefore, y is equal to cos inverse of cos of e raised to x minus alpha. So y is equal to e raised to x minus alpha and alpha is equal to tan inverse of 2 upon 3. So differentiating, derivative of e raised to x is e raised to x and derivative of alpha is 0. So the derivative of the given expression is e raised to x. Now the next example is differentiate the following with respect to x. Cosec inverse of 10 upon 6 sin 2 raised to x minus 8 cos 2 raised to x. This example is similar to the previous one, only the term is taken at the denominator. So here we have to use the property. Cosec inverse of 1 upon x is nothing but sin inverse of x. Okay, so sin inverse of x. So we have taken the reciprocal of these terms. We get 6 sin e raised to 2 raised to x minus 8 cos 2 raised to x upon 10. Now we will divide the numerator separately by this 10. So sin 2 raised to x into 3 upon 5 minus cos 2 raised to x into 4 upon 5. After dividing 10 separately, 6 by 10 and 8 by 10, we got this term. Now here there is a sin inverse. So in bracket, after simplification, we must get sin a plus b or sin a minus b. For that, I have to take this 3 upon 5 as cos alpha. Okay, and after simplifying, I have to prove that this 4 by 5 must be equal to sin alpha. Okay, so I can put these values in the expression. Y is equal to sin inverse of sin 2 raised to x cos alpha minus cos 2 raised to x sin alpha. Okay, so y is equal to sin inverse of sin 2 raised to x minus alpha. Therefore y is equal to 2 raised to x minus sin alpha, because again using the property sin inverse of sin x is x. Now differentiate with respect to x. Derivative of a raised to x is a raised to x log a. So derivative of 2 raised to x is 2 raised to x log 2. And alpha is tan inverse of 4 upon 3, which is per purely constant number. So its derivative is 0. So what we get? Dy by dx is equal to 2 raised to x log 2. So these are the examples from exercise 1.2. We will still continue the same exercise in our next lecture.